Welcome to the Commercial Lighting Requirements of the 2006 International Energy Conservation Code training video brought to you by the U.S. Department of Energy. You now can receive .10 CEUs towards IECC renewal certification and/or 1.0 AIA CES learning units. However, in order to obtain AIA LUs, new AIA requirements dictated tests must be taken. At the end of this training video, you will be directed to a website to take the 10-question test, applicable to AIA members only. You must answer 8 of the 10 questions correctly in order to qualify for the 1.0 learning unit. BECP will report the AIA members who pass the test so credit can be awarded. A certificate of completion will also be available at the end of this training video.
Thank you, and welcome to the Commercial Lighting Requirements of the 2006 International Energy Conservation Code. As you know, this is one in a series of 3 presentations on the 2006 IECC. This one is specifically on the lighting portions of that code and how they apply to various energy code compliance in various states throughout the country. We would like to cover certain things in this webcast. First, we'd like to provide a little bit of history and basis for the codes and the standards, why we have them, where they came from, and where they would apply to individual jobs and tasks. We'd also like to spend most of the time on the specific requirements. And again, this webcast is on the IECC 2006, so that's what we're going to focus on. But wherever it makes sense for application to other states and other jobs, we'd like to provide some comparisons with other codes and standards, again, where that's applicable and where it makes sense. We also like to intersperse within the specific requirements some of the intent, what the intent of the code provisions are of the major requirements, and what the requirements actually mean in actual practice. Because as we all know, code language is sometimes confusing, and we want to make sure that everyone understands what it actually means, and therefore people can apply it to their projects. Some history on the basis for energy requirements in the United States.
As you may know, the Energy Conservation and Production Act, as amended by EPAC, provides a requirement that states adopt a commercial energy code that meets a certain stringency level. And this requirement is what has driven states to adopt energy codes in one form or another. The stringency level is a task that was taken up by DOE, and their current determination is that the ASHRAE ISNA 90.1-1999 is the standard level of stringency that must be met by this requirement.
And states are in various stages of doing that. See later on, there are many different codes and standards, many versions of them available that are currently adopted by states, and it depends entirely on the state legislature what they decide they want to adopt and when they want to adopt it. So what you have are a lot of different codes out there. Not every state has adopted the same code, and that makes it tough for people who do particularly work in multiple states. Some states will adopt a nationally available code, such as the IECC or the ASHRAE ISNA 90.1. Some states will develop their own state-specific codes, and this can vary from a completely written from the bottom-up code done by states themselves or contractors, or it could be a nationally available code, for example, that was adopted by a state with some modifications, which could be minor administrative items or major requirements that they decided weren't applicable in their state. Whatever the reason, they would have some modifications. And then, of course, there are a few states that, in spite of the Energy Policy Act requirement, do not have a code yet. Most states, of course, have done something in terms of looking to adopt a code, but not all of them have adopted one yet. So let's look at somewhat of a timeline to give you an idea of all the variety of codes that are out there. You'll see there are 4 basic paths: codes, standards, federal, and state-specific. The codes are listed as such because the ones in that path, Model Energy Code and IECC, were written originally in code language. They were written by code developers or building officials, so they were in code language. Started off with the Model Energy Code, which was basically just a residential code that referenced a commercial standard It's then moved to the IECC, which incorporates requirements for both commercial and residential. Standards are listed as standards, and this refers to the ASHRAE ISNA standard development process. And again, it's listed as standards because it was originally written as a standard for how to build energy-efficient buildings, not necessarily as code language. However, as time went on, this changed, and now they are written in code language so that states can adopt them and use them as their energy code. The federal track, again, the federal government has its own codes for its own facilities. These codes are essentially based directly on the ASHRAE codes. That's where the provisions primarily come from. And state-specific, as we mentioned before, a state can decide to develop its own code or base it on one of the nationally available codes with some adjustments. And you'll see, particularly between the codes and standards area, there are a lot of links between the two. This is primarily because the Model Energy Code and IECC have references to ASHRAE as either the primary or an alternate commercial code. And we will talk about that a little bit later on as well. So let's move to the actual requirements in IECC 2006. In the 2006 document, the commercial provisions are contained in Chapter 5. The other chapters deal with administrative definitions, residential requirements, and such. Chapter 5 is the commercial, and it does have, as mentioned before, a reference to ASHRAE 90.1 as an alternate complying code. So if you don't want to comply with the Chapter 5 requirements in IECC, you can opt to go with compliance to ASHRAE 90.1. And in this case, IECC 2006 references the 2004 version of ASHRAE, so that's one you would need to comply with. The actual IECC Chapter 5 itself covers lighting controls and power density or allowances for both interior and exterior applications, so it covers the entire building. There is one notable exception to all of the requirements, and that's lighting within dwelling units. And dwelling units, just to make it clear, is defined as the actual personal, complete living space. So, for example, an apartment, a personal apartment, all of the apartment spaces would be considered part of the dwelling unit, and none of that lighting would have to meet any of the requirements of the Energy Code. However, outside of the apartment, the hallways, lobby, and spaces like those would be subject to the requirements of the Energy Code. There are a couple of major changes in the 2006 version of the IECC compared to previous versions. One is that the interior lighting power allowances have been revised. Now, the numbers haven't changed in stringency from previous versions, but the format has been revised such that you only have one table instead of two, and we'll talk about that in detail later on. The other one is that whereas previously there were very limited requirements for the exterior lighting in terms of controls and power densities, there's now a brand new, very detailed section for exterior lighting power developed through the ASHRAE process, which has been adopted by IECC 2006 as well. Now let's look briefly at the code compliance process. And for IECC, you of course have to start with deciding whether the project has to comply with the IECC, and in particular this code. If it's determined that it is, then you have three basic compliance sections, one for envelope, one for mechanical, and one for lighting. And of course, this session is talking about the lighting itself. For each of those sections, there are, as you can see, a couple of different ways to comply. One is within IECC, and one is the ASHRAE reference. And again, we'll talk about that a little bit. And once you show compliance, of course, you document that, and you will typically go through a plan review to get a building permit, and there will be or can be inspections, just like there are for any code provisions other than energy. So let's go to that first box where the question is, does my project need to comply with the commercial requirements of IECC? First, you need to decide if IECC, and particularly for this presentation, whether IECC 2006 is the applicable code in your state or jurisdiction. It may be, as you've seen from the charts before, it could be some other code. It could be an ASHRAE code. It could be a previous version of IECC. If it is, you need to go with that code. But assuming that you have a state where IECC 2006 is the code you have to go with, then you need to find out if you are truly a commercial building. And a commercial building, of course, is any commercial business or a high-rise residential. Now, if your residential is a 1 or 2 family or is an R2, 3, or 4 structure 3 stories or less in height, those would be considered residential and not commercial. But anything above that would be considered commercial and have to comply with the commercial requirements of the code. Now, when do the lighting and power requirements apply to your building? If it is an original installed lighting system in a new building or in an addition or in a tenant build-out, if you have a core and shell building that went up and a tenant's going to move in with their own lighting system, that also would need to show compliance. If you have an existing lighting system and there's a remodel to the building and the lighting system is being completely altered or being replaced, that would also need to comply with the code. And one other one is that if there is a change in occupancy, if you have a building, say there was a warehouse and you're going to turn it into a restaurant, for example, that would obviously increase the energy use in the building, and that would also trigger the compliance requirements. There are some exceptions to when you don't have to comply with the lighting. One would be historic buildings, and there are various levels of historic building status. There are state listings and national listings. If you're on one of those listings or if you've been deemed eligible to be on one of those listings, you don't have to comply. There are some other historic building possibilities also, which have to do with regional listings or if you're associated with another historic site. And those will be done mostly on a case-by-case basis, working with the building official to gain that kind of exception. The other exception, as mentioned before, is lighting within dwelling units. Of course, that's just the dwelling unit part. Any lighting outside, corridors, lobbies, etc., would still have to comply with code. So let's look again at the compliance process. We're, of course, dealing with the lighting section. You need to comply with the power and lighting requirements. It's mostly lighting. There is a little bit of power requirement. And as mentioned before, there are 2 paths. The IECC Section 505 are the actual requirements within the IECC document. If you choose not to comply with those, for whatever reason, you can opt to use the 90.1 2004 reference, which is Section 9 in that document. There's one other box down here you'll see that's been added, and I want to talk briefly about this. We won't spend a lot of time with it, but it is a alternate path to the prescriptive paths. It exists in both IECC and ASHRAE in different sections. In IECC, it's Section 506, and they're generally referred to as building performance methods. And what this is a complete whole building modeling using some approved software product where the schedules and characteristics of the building are input, and the energy use is run for a building as if it would just meet the prescriptive requirements of either IECC or ASHRAE. And then you input the requirements or the design for your building, the way it's going to be designed and built. And if your energy use is at least as low as the base building, then you comply with the code. Of course, this is a more complicated system, requires a lot of modeling inputs and a lot more work and generally a lot more expense. And it's usually not done this way unless there are some reasons why you can't comply prescriptively. And usually this is only limited to larger, more complicated structures or ones that have an unusual system of heating and cooling, for example, might be a reason to do that. So let's move into what's covered in the electric power and lighting section, if this is what you have to comply with. The section includes some mandatory interior lighting requirements. These would be some required controls for the lighting systems. There are also some a couple of wattage efficiency type limits and requirements, and of course we'll go over all these in detail. The section also includes interior lighting power allowances, or densities you may have heard it referred to, watts per square foot limits on the lighting power you can use. And for exterior, it's similar. There are some required controls that you have to meet, and there is a lamp efficiency requirement that we will talk about as well. And again, similar to interior, there are exterior lighting power allowances, again, watts per square foot limits, which are muchly expanded in the 2006 version of IECC. And there is one electric metering requirement, just the one which we will cover as well. So let's move directly into the mandatory requirements, the interior lighting control requirements. The first one is a basic, straightforward control requirement that says independent control is required for each space surrounded by floor-to-ceiling height partitions. And of course, the intent here is to allow occupants to control unneeded lighting. If they don't have the control available to them, they won't be able to save any energy, essentially, is the intent here. And this can be complied with a switch that's located in the space so occupants can see it. However, if you have reason not to do that, you can have a switch from a remote location. But the switch must have an indicator of some type that identifies the lights that are served by that switch and the status of the lights, either on and off. And typically this would be a pilot light next to it that would indicate the status of the circuit. There are exemptions to this basic control requirement. If you have security or emergency areas that must be continuously lighted, of course, there's no reason for a control. You don't have to have one. Also, the IECC specifically exempts lighting in stairways or corridors that are elements of the means of egress. So if you identify spaces like that, make that case to the building official, and that would be exempted as well for those particular spaces. So a little more on interior lighting control. There's another major requirement for light reduction, and you may know this as bilevel switching. It's a similar requirement, just the name has been changed. Essentially, it requires that the occupants be able to reduce the connected lighting, and they must be able to reduce it by at least 50%, and it must be done in some reasonably uniform pattern. And there are different ways to comply with this, which we'll show you. Again, the intent here is to allow the occupants, when they feel it's possible, to reduce their light level. Perhaps they're near a window and can take advantage of daylight, or perhaps they're doing some tasks with computer screens and they don't want as much light, or they don't have as critical tasks and they would prefer to use less. The idea is to encourage them to use less. One note here that the alternate compliance path, ASHRAE ISNA 90.1 2004, does not require light reduction control. So if you were to go with that option, you wouldn't have to put in these controls. Now let's look at some ways to comply with this, some light reduction control options. One of them is controlling all of the lamps or luminaires, and essentially this means a dimming system where you reduce the energy input to all of the lights. Another option is dual switching of alternate rows or alternate luminaires. Again, the idea being that this is a uniform pattern across the ceiling grid. Another method would be to switch, and this would be if you have, for example, 3 lamp fixtures, you would switch middle lamp luminaires independently from the outer lamps. This would be relatively uniform, and you would also be able to meet the minimum 50% requirement with this. Another option, of course, would be each luminaire or each lamp. This isn't going to be commonly done because of cost and just practicality, but it is another option. So one more bit on the light reduction requirements. There are some exemptions to this control requirement. It's not required in the following areas. If you have only one luminaire, of course, there's no real reason or practicality to reduce it. If the area is controlled by an occupancy sensor, you've already got the control to really reduce energy use, and so the control is not required in that case. And again, IECC 2006 exempts specific spaces, corridors, storerooms, restrooms, or public lobbies, and these are basically for practicality purposes, no other reason really. Sleeping units are also added to the exemption list. And here we have a different term. It sounds like dwelling unit, but sleeping unit is a different defined term. A sleeping unit is the bedroom, let's say, in a hotel or a motel. It's not your permanent place of residence. It would be a rented room, hotel, motel, dormitory type situation. Again, the sleeping room would be exempted from this requirement. However, the corridors, lobby spaces, etc., would still have to meet these requirements. And finally, if you have a low energy use area, say a very low energy warehouse, for example, any space that has less than 0.6 watt per square foot load in energy, it's not required to have this control, again, for practicality reasons. That takes care of it for light reduction requirement. There's another major requirement called automatic shutoff. And this requires that if you have a building larger than 5,000 square feet, you must have a way of automatically shutting off the lighting to the building. And one important point here, we need to kind of define what building is for this control. Typically, a building is any structure used or intended for supporting or sheltering occupancy. In the case of this control requirement, there's another way to define it, and that is a building area surrounded by exterior walls and firewalls. And the firewall part is the important point here, in that for example, if you have a strip mall that's 10,000 square feet, you would say, okay, it's over 5,000 square feet, it has to have this control requirement. However, the strip mall typically has individual retail or office units, and each of those might be less than 5,000 square feet, and there it's not practical for cost and installation reasons to have a whole building type controller, and therefore it would not be required in that case. So if you have, for example, again, a strip mall with firewalls between each business, each individual business, if it's less than 5,000 square feet, would not be required to have that control. There are some other exempted spaces. Again, sleeping units we've talked about would not have to have this control. If you have areas with patient care, you don't want to have automatic control to shut off lights when they need to be on. Those would be exempted. If you have any other areas where there might be an occupant safety or danger situation, for example, a mechanical room where someone might be in the back maintaining some equipment, you don't want the lights going off on them if there's running equipment around them. So those would not be required to comply here either. And again, the intent of this automatic shut-off control is simply to eliminate waste light when people aren't in the space, typically after hours. Now, there are several ways of complying with this control option. So it's not just one method. There are different ways you can do this. The first one would be perhaps the simplest in some building situations, in that there is a scheduled basis or an automatic time switch that sweeps 4 by 4, for example, or space by space, and turns off a light a certain time period after the business is over. If the office is closed at 5 and employees are gone typically by 6, there might be a sweep that goes through and turns everything off at 6 o'clock. This must be a time of day type controller, and there is a limit in that it controls not more than 25,000 square feet and not more than one floor for each circuit, so there's a little bit of flexibility. A second way to comply with this requirement is by the use of occupancy sensors. If you, for example, have a smaller building and you really don't need a whole building control, if you have occupancy sensors in each of the spaces that will turn lights off within 30 minutes or less of the occupant leaving the space, this provides the same control. In fact, one would argue this is even better control and would be preferred in a lot of cases. But anyway, this is a second way to comply. The third one is somewhat of a catch-all category, realizing that there are a lot of control development going on, and there's new systems being brought on all the time. So if there is some other kind of system, say a workstation control system or a telephone security system that can be tied into the lighting, that could be used as well to turn off lights when occupants have left. The diagram to the right shows you a combination, just to get the point across. So you don't have to do one or the other of these. You could have a combination. And in this case, in the major open bay office area, there is an automatic lighting control switch that sweeps the lights, whereas and it includes the lobby. Whereas in the restroom, the office, and the conference room, there are individual occupancy sensors for practical reasons. And this combination does comply with the code, and it makes a lot of sense in this case. One more part to the automatic shutoff. If you are required to install automatic shutoff, you must also install override, and this is to give occupants the capability to come in after hours, for example, and do some work and be able to turn the lights on when they need them. This override needs to be readily accessible to the occupants. It needs to be within view of the lights or the area it's controlling. It needs to be manually operated, and it should have a less than or equal to 2-hour override, no more than that, and cannot control an area any larger than 5,000 square feet for each control point. And as with every other requirement, there are some exemptions to this. If you have a mall or arcade, auditorium, retail space, industrial facility, or arena that are using captive key override, then you can have a longer than 2-hour override period. And also, the second exemption, if you have one of these same kinds of spaces, you can have a control point cover up to 20,000 square feet. It wouldn't be limited to the 5,000 square feet. And again, this is because those spaces tend to be larger to begin with, and you can see them as one large space. They're not broken up. That's the main situation there. So a final minor point to this control requirement is that you also have to have the capability of holiday scheduling. The feature would then be able to schedule turning off all loads for a 24-hour period during the holiday and then resuming the normal schedule after the holiday. And there are some exemptions to this. Some spaces, retail stores, associated malls, restaurants, grocery stores, places of religious worship, and theaters are exempt because the holiday switching generally doesn't apply because holidays don't apply in those type of retail businesses that they might to offices or other types of facilities. That takes care of automatic lighting shutoff. There are a couple of other smaller specific requirements. One has to do with sleeping unit control. And again, a sleeping unit is like a hotel or motel bedroom. The control requirement applies to, again, hotel, motel, guest room, boarding room, houses, or similar facilities. And the requirement is that there must be a master switch at each room or main room entry that allows you to turn off all the permanently wired luminaires and any switched receptacles. The intent here, of course, is to allow the occupant to turn off the lights in the guest room or suite without having to go back and turn off individual lamps or individual fixtures on the wall. As you can see from the two diagrams, if you have a standard room, there's going to be one switch at the exit door. However, if you have a suite with an interior bedroom, for example, you are allowed to have a master switch at each of the rooms. So as you leave each room, you can turn off the lights to that room, and that would meet the intent of the requirement. Another specific requirement has to do with tandem wiring, and the basic requirement is that tandem wiring for all odd-numbered lamp configurations must be done for those fixtures. And the intent here is to eliminate the use of magnetic ballast driving single lamps. Because as we know, most magnetic ballasts are meant to drive two or more lamps, and when you drive one of them, you have a lot of waste. This isn't the case with electronic ballasts, so there are some exceptions. If you have electronic high-frequency ballasts, whether they're single lamp, double, triple, whatever, those are allowed without any restrictions. If you have luminaires on emergency circuits, those you don't have to tandem wire. And if you have luminaires, of course, with no available pair in the same area, then there's no capability to tandem wire, and it would not be required. This kind of situation doesn't happen much anymore with the proliferation of electronic ballast, but it still occurs occasionally, and you do need to be tandem wired in those situations. One other small requirement is for exit signs, and the simple requirement is that internally illuminated exit signs shall not exceed 5 watts per side. And with today's technology, with LED exit signs, etc., there's no issue really with meeting this requirement. It's very commonly done. That takes care of the mandatory control type requirements. The other major requirement for interior lighting is on the interior lighting power limits, and this is where you're allowed a certain wattage limit that you can't go over and still meet the code. The basic requirement is that your connected interior lighting power must not exceed the interior lighting power allowance for that building type. And 3 simple steps here. You calculate the interior lighting power allowance based on the values given in the code itself. And this is based on building area type, and we'll discuss that a little bit in detail. And there is an additional allowance that you are allowed for retail, which we will talk about also, which can help increase your allowance for special retail needs. The second step is to calculate your proposed connected lighting power. This would be the lights you're going to put into the building as part of the building design. There are some what we'll refer to as wattage calculation rules that we'll talk about in how you calculate your proposed lighting. And there is some exempted lighting, some lighting functions you do not have to include in the calculation that are exempted. The third step, of course, is simply to compare the two values, and your proposed wattage must be less than or equal to the allowed wattage for you to comply with this requirement. The intent here, of course, is to eliminate waste from sloppy lighting designs and applications. A lot of designs have simply been done a certain way for a long, long time based on old requirements or old norms, and the code wants users and designers to think about their designs and make sure they aren't being sloppy or wasteful. So let's look at the table and what the requirements actually are, what this looks like. There's kind of a small version of the table, but gives you an idea of what it looks like. The revision is mentioned in one of the first slides in the presentation was that there's one table now instead of one table with only one column of numbers instead of 2 columns of numbers. As you may recall, in previous versions, 2003 IECC, for example, there was a similar table with similar space and building types, but you had a tenant area number as well as a whole building number, and you could use either compliance path. For 2006, for reasons of simplicity, it's been reduced to just a building area type basis only, but the retail additional allowance has been retained. For previous versions, there was a decorative allowance and an allowance for some medical spaces, but those have been eliminated for the 2006 version. And a note here, the alternate standard ASHRAE 90.1 2004 still provides a whole building and space-by-space option. And there are a lot more spaces in the 2004 table, and that may be something you might want to consider as an option in the future. So let's look at the actual allowance calculation. First, you would choose an appropriate building type from the allowance table. And a building area, again, as we briefly explained before, includes all the different spaces within that function type. So, for example, if you have a building that includes corridors, restrooms, a lobby, and some office space, this would be considered an office building area type, and you would pick that value from the table. Then, once you've chosen that number, you multiply that lighting power density from the table, watts per square foot, by the building square footage to get your allowed watts for that building for compliance. Let's look at an example for an office building type. It's a 200,000 square foot office. Again, it contains corridors, restrooms, break rooms, etc. But it is an office building type, so it's given 1 watt per square foot for the entire building. So you multiply the 200,000 square feet times the 1 watt, and you get 200,000 watts for compliance for that particular project. Now, what if you have a building that has multiple occupancy types? This is also taken care of with the same table. For example, if we had a building that was primarily a museum, but it also had some retail space for souvenirs and also had a cafeteria for people to eat while they're visiting, what would you do with that? In this case, the rule is that you use the more specific building area type, if it exists on the table, and apply that to each of the different building area space types within that one structure. Then you sum the individual lighting power density times area square footage values, and you get a total power allowance for that building. And let's look at that as an example also, showing you the table. Got the museum at 40,000 square feet, it's 1.1 watts per square foot, get 44,000 watts for that. Cafeteria is 10,000 square feet at 1.4 watts, etc. Retail, 5,000 square feet at 1.5 watts. You get 3 different wattage values, and you add those up. That's your total allowance for that building. It works in very much the same way as a single occupancy building. Now, there is an additional lighting power allowance, which is a footnote in that table, which is the one that was retained in the 2006 IECC, and that's for retail. The intent here, of course, is to allow flexibility for designing critical retail applications. As everyone knows, lighting is very important to the sales of merchandise, and so there need to be special accommodations made for specific highlighting of merchandise in addition to overhead lighting. So the allowance is provided for lighting that is installed to highlight specific merchandise, and that must be in addition to general lighting. It cannot be the same general lighting used for occupants to move around in the space, for example. This additional lighting is then added to your general lighting allowance, and that increases the allowed wattage you have to meet with your installed design. There are 2 levels of the allowance. The first is the basic 1.6 watts per square foot, and this is times the display area, but the display area cannot exceed 50% of the floor area. And I want to talk a little bit about this display area term. Now, that doesn't mean the floor area where the merchandise is placed, for example. It truly does mean a display area that's being specifically highlighted. So, for example, if you had a wall of shoes and you had some general lighting in the space, but you also had some track lighting near the wall that was aimed at that wall of shoes and was highlighting each group of shoes, for example, so that the entire wall display was highlighted by those track lights, that would be considered an appropriate display area that would receive one of these allowances. In this case, it would be the 1.6 watts per square foot. Similarly, if you had a shelf or a tabletop that had some merchandise on it and there was some specific fixture aimed at that surface, that would then allow you this additional wattage. If you have overhead lighting that is just shining down on a tabletop surface, that would not get this additional allowance. It has to be highlighted merchandise and it has to be specific fixtures aimed at that merchandise. The second category is for specific merchandise types, either higher-end jewelry, china, and silver merchandise, and this allowance is at 3.9 watts per square foot, again, times the actual case or shelf area, not a square footage of the sales floor. Now, an important note here is that this display lighting does need to be separate. It must be separately switched or dimmed on a separate circuit from the general lighting. It cannot be part of the general lighting to get this allowance. So let's look at an example with this retail allowance. It's the same example we looked at before, but in this case, in the retail 5,000 square foot space, we have some wall display. Let's say it's 10 by 40, 400 square feet at 1.6 watts per square foot. We get an additional 640 watts. Add that to your initial value, get a new total of 66,140 watts. And the red dotted line there in the corner is the footnote. That's where this allowance comes from. It describes where you can apply it and how it's applied. So we've calculated the allowance. Now let's look at the lighting power that we're going to put into the building. The rule again is you sum the wattage of all your proposed connected lighting power, all of your luminaires, all the lighting functions, and this must include everything that's on the design for the space. This means overhead lighting and task lighting and decorative lighting. If they're part of the design, they must be included. Now, there are a couple of cases here we can talk about. One would be if you design an office space, for example, and the tenant is going to move in their own furniture, and say they purchase furniture that has under cabinet task lights, for example, or under shelf task lights within the furniture. If that was not part of the original design of the space, that does not have to be included. That would be something that comes in later. However, if a space is designed with task ambient lighting, a certain amount of overhead with the understanding that there would be some task and that's described in the design, then that does have to be included. Decorative lighting, even if it's there for decorative purposes, is also included in the design and must be included. And note that the wattage must be calculated based on actual power draw, not just nominal lamp rating. So the calculation is looking for lamp plus ballast values when there is a ballast associated with that. So let's look at an example here. Again, the lighting must be, wattage must be documented in accordance with section 50551. That's where all the rules come from. And there are some specific rules here. For screw lamp holders or Edison-based sockets, typically downlights, it's the maximum rated wattage of the luminaire. So when they come from the manufacturer, they will likely have a label that says the maximum wattage you can put in this fixture is, say, a 75-watt lamp. That's the rating you have to use. And if you're putting in a lower wattage, that might be a problem showing compliance. If you can find a fixture that somehow can be labeled with the wattage you're going to put in it, that would be much better for your compliance. For low voltage lighting, it will be the transformer value for that low voltage system that you have to include for your wattage calculation. If you have line voltage track, you need to use the greater of either 30 watts per linear foot of track or the actual wattage of the heads that you're planning on putting on that track system. Now, this can also be a problem if you put in a lot of track for flexibility but very few heads. You are, unfortunately, going to be stuck with that 30 watts per linear foot. But that's the way the code was written. Again, the intent here is to make sure that people don't put in a lot of track but only claim a few heads and are therefore underrepresenting what the actual wattage will be. Anything else besides these three specific items would be the manufacturer's rated wattage of the lamp and associated ballast. So if it's a fluorescent system, it has to be the lamp plus ballast value. And typically you're going to find these values in the ballast manufacturer's cut sheet. They will have the wattage draw of their ballast with the typical type of lamp that you're going to apply to it. That's where you get the typical ratings from. At the bottom of this is a simple example of one accounting of a series of luminaires. There's the ballast type, the lamp plus ballast wattage from the cut sheets, number of lamps per luminaire, the quantity of luminaires, and the total wattage. This will be the number, in this case, the 14,692 would be the number you would be comparing with the allowance that you calculated earlier. Now, as mentioned, there are some exemptions to what you have to count when you're counting up your proposed lighting power. There are certain fixtures or functions you do not have to include. Specialized medical, dental, or research lighting does not have to be included. Now, this would be lighting in addition to the general lighting that's there specifically for performing medical, dental, or research functions. If you have any professional sports area playing field lighting, that would be exempt. But again, this is professional sports and it's playing field lighting only. If you have any display lighting for exhibits in a museum, gallery, or a monument, that's also exempted. Again, this is the display lighting. It's not the overhead lighting in the general space. Sleeping unit lighting, as described before in hotels, motels, boarding houses, etc., is exempt. And if you have any emergency lighting, it is automatically off during normal building operation. For example, one of the battery-operated power packs that you see in that photo, those will be exempted as well. Now, what if the proposed design does not meet the code the first time you try it? There are a couple things you can look at. First, you want to check your calculations in your design. Have you picked the appropriate building types to get your allowance? Have you used the actual lighting equipment wattages? If you're using defaults, you might want to think about that because the actual lighting equipment power might be less than defaults, and that would be better for you. You also want to look at the design. Do you have reasonable illuminance levels? A lot of spaces are over-designed, and you would want to look at that and make sure that you have reasonable levels. You also want to look and see if you've used the most efficient light sources possible. If you have the capability of using something more efficient than, say, an incandescent, you should go ahead and try and do that. If this doesn't work, you've checked everything, there are a couple of alternatives. You can go to the alternate 90.1 2004 standard. Now, this won't necessarily give you any advantage other than you can maybe use these space-by-space tables, which had a lot more offerings of wattage allowances. That might give a little bit of an edge. The numbers you'll find between 2004 and 2006 in terms of stringency are the same, where there is a matching building type. But it might work. It might be worth a try. If that doesn't work, there's another option, which again is using the total building performance method that we talked about briefly before. But this, of course, involves whole building modeling. It's a lot more work. And again, you may want to only consider that with a larger, more complicated building. That pretty much sums up what's required for interior lighting. Let's move on to the exterior lighting requirements. The first is a control requirement, and there's basically just one for exterior lighting. It states that if you have any lighting that's designed for dusk to dawn operation, you must control that by either an astronomical time clock or a photocell. Either one of those would comply with the code. If you have other exterior lighting that is not designated for dusk to dawn, but it's timed, then you must use some sort of an astronomical time switch to control that lighting, turn it on and off when it's not needed. There are, again, exceptions to this requirement. If you have lighting in covered vehicle, parking, entrances or exits from buildings or parking structures, if it's required by safety, security, or adaptation, in any of those cases, you can be exempted from this requirement as well, because it wouldn't make sense to have the control in that case. Each of these exceptions, of course, you would want to document in some fashion to the building official to state that this is the case and therefore you get the exemption. There's another efficiency requirement for exterior lighting. This has to do specifically with building grounds lighting and for any luminaires that are running at over 100 watts. These must have a source efficacy of at least 60 lumens per watt. And if you look at the table that's provided here, to give you a rough idea of what will probably fly and what won't, as you can see, the incandescent and halogen sources are simply not efficient enough, and you wouldn't be able to use those for, again, luminaires over 100 watts. Only over 100 watts. Below that, you could use those. Some compact fluorescent might work in the higher efficiency end, and certainly linear fluorescence and metal halide would be able to comply with those requirements, depending on which type you chose. There are some exemptions to this requirement. If the lighting is controlled by a motion sensor, it can be any efficiency you choose. If any of the exterior power allowance exemptions, which we are going to go over in a few slides, are applicable, then it's exempted as well. And like with a lot of other lighting requirements, if it's approved for a historical, safety, signage, or emergency consideration, it's exempted. And again, you would want to make these cases individually to the building official and document that this is the case and therefore you're exempted from that requirement. On to the exterior lighting power limits. This is similar to what you've just seen for the interior. And again, as I mentioned, this is new for the 2006 IECC, came from the ASHRAE development process, and is therefore the same as the ASHRAE code that's referenced in IECC. It's a connected exterior lighting power requirement that the exterior lighting power must not exceed the lighting power allowance for exterior. Same method as for the interior. And the same basic three steps, you calculate your exterior lighting power allowance, and this again is based on the exterior function. Each function has its own lighting power density. There is a little bit of difference here in that for exterior, you do get to add an additional 5% of the total allowance that you can use wherever you want. And the intent of that 5% adder is that it allows some flexibility, because all designs are different and there may be something that's just not covered in the code that you need some extra lighting for, and that 5% provides you some flexibility there. Second step, of course, is to calculate what you're planning on putting in as part of your design. And there are, again, some wattage calculation rules. And there is some exempted lighting, some lighting systems or functions you don't have to include in your connected lighting power. Then, of course, you compare the two values, and your proposed wattage must be less than or equal to the allowed wattage for you to comply. So let's look at what's included in the allowances. In the exterior, there are two basic sections. One is tradable surfaces, and it's called tradable surfaces because when you calculate your allowance, you're basing it on all the spaces you have, but it becomes one total. Just like in the interior lighting, you can use that allowed lighting power for any fixture you want on the exterior. This is the same system as in the interior. And this includes the common exterior lighting surfaces. And that would include things like parking lots, for example. And in this case, just to give you an idea what the trading is like, if you have a certain wattage allowed for parking lot lighting, but you don't use all of it, you can then use some of that that's left over for, say, canopy lighting or something else where you're underrepresented in wattage. The second category are the non-tradable surfaces, and these are generally less common exterior surfaces, not usually found in all buildings, and they cannot be traded. In other words, you can't swap these around between different applications. The reason being that these applications have more of a specific security requirement or a cast illuminance need. And we'll show an example of what these are like. So let's look at tradable surfaces. Here's the list of what they are: uncovered parking lots and areas, walkways, and there are two categories: under and over 10 feet wide, stairways, main building entrances, other doors, canopies and overhangs, both freestanding and attached, and open sales areas in kind of two categories: the open area and the street frontage. All of these, again, are tradable. If you don't need all your parking lot allowance, you can use it for something else. Non-tradable surfaces. These are those specific ones. Building facades are common, that's true, but they're specifically in the non-tradable section because there are specific limits required for those. Automated teller machines and night depositories certainly have a safety requirement, as do entrances and J-house inspection stations at guarded facilities, loading areas for law enforcement, fire, ambulance, etc. Drive-up windows at fast food restaurants have some specific illuminance requirements, and parking near 24-hour retail entrances also has some high adaptation and security requirements. These, again, are non-tradable. If you get an allowance for an automated teller machine, for example, you cannot use any leftover wattage for any other place in your exterior lighting. So let's look at an example. Here's a typical bank building. It has a canopy out front, has a walkway that's 5 feet wide, has a parking area and it has one ATM. So we need to determine how many tradable and how many non-tradable watts we have and calculate our allowance. So let's look at an allowance specific calculation. We have a parking area, 10,000 square feet, and I'm sorry, first look at the table to your right. You'll see it's kind of hard to read, but there is a tradable section at the top and a non-tradable section at the bottom. So parking area, 10,000 square feet at 0.15 watts per square foot, a canopy at 100 feet at 1.25 watts per square foot. You have a walkway, which is less than 10 feet, so it gets 1 watt per square foot times the 200 feet length. And you have one ATM, so you get 270 watts for the ATM. And again, I know I've mentioned this before, but that 270 watts can only be used for the ATM. If you only need 200 watts for your ATM, you can't use that 70 watts somewhere else. The total here comes to 2,095 watts. And as we mentioned before, there is the 5% adder. Now, the 5% applies to both tradable and non-tradable wattage. So you take that total, multiply by 1.05, and you get a new allowed total of 2,200 watts. That's your base value that you need to comply with. You need to have exterior lighting that is that amount or less in order for you to comply. Now, as mentioned, there are exemptions from the exterior calculation. These are lighting. This is lighting you do not have to include when you're calculating your designed exterior lighting power. The first one is specialized signal, directional, and marker lighting, and this will be those functions associated with transportation. You have advertising signage or directional signage. Those do not have to be included. If you have any lighting that came with a piece of equipment, was installed by the manufacturer, for example, that lighting does not have to be included as well. If you have any outdoor theatrical purposes, performance, stage, film production, video production going on, the lighting that's specifically for those functions does not have to be counted. Now, if it's general lighting for the area, that would have to be counted. It would only be the lighting that's activated specifically for those purposes that would be exempted. If you have any lighting for an athletic playing area, the playing field lighting itself would also be exempted. If you have any temporary lighting, of course, it's not going to be there permanently. It does not have to be included. If you have any industrial production functions going on outside or similar material handling or transportation associated with those or storage areas, those do not have to be included. If you have theme elements for a theme or amusement park, so for example, exterior parts of Disneyland or some exterior theme elements for casinos, for example, those would be exempted and would not have to be included. If you have any lighting that's used to highlight features of a public monument, again, the registered historic exemption, anything for a historic landmark, structure, or building, that lighting would be exempted as well. These do not have to be included in your calculation. Now, once you have your calculation of proposed wattage and you compare it with your allowed wattage, you hopefully will meet code. Now, what if you don't meet the proposed exterior lighting code requirements? Again, similar to the interior situation, you need to check your calculations of design, find out if you use the appropriate exterior surfaces, look and see if you've got the correct wattage you're using, and of course look at your design. Again, reasonable illuminance levels provided. It's very easy to overlight spaces for a variety of reasons, some of them not so rational and some rational, but you need to look at that and make sure that your design is appropriate. And also look at your light sources. Perhaps there are some outdoor functions that you can use a more efficient light source for. And again, as before, you can use the total building performance method of compliance, but again, that's a lot more complicated. You'll notice that unlike the interior situation, the exterior does not list using the alternate lighting standard. You can do that, but that won't help you really in any way for exterior lighting because the requirements you'll find are essentially identical for exterior lighting in the alternate standard as well as IECC 2006. That completes the requirements for exterior. As I mentioned, there was one requirement for electric energy consumption. There was a metering requirement, and this applies specifically to dwelling units, and this would be 4 stories or above, multiple dwelling units. If you have that kind of a building, there is a requirement that each dwelling unit have its own meter. And the intent here, of course, is that if an occupant understands what their energy use is, they'll have a better chance of actually affecting it. That's the reason for it. and that's what the requirement comes from. That takes care of the lighting and power requirements for IECC 2006.
This ends the training video. If you would like to take the test to receive AIA credit and or print a certificate of completion, please write down the URL shown on the screen. You will need to type this URL into your internet browser. Thank you.